Let's solve this problem. Again, I am assuming that it is a byte addressable system. They have given that physical address space equal to 256 MB. 256 MB is nothing but 2 power 8 into 2 power 20, which is nothing but 2 power 28 bytes. Right? 256 is 2 power 8, this is 2 power 20, 2 power 8 into 2 power 20 is 2 power 28 bytes. And page size equal to 2 power 12 bytes and number of pages is 2 power 8. They are asking all these things. Now from this we can say that from physical address space we can say that number of bits in physical address will be equal to 28 bits. Now our physical address will have two fields, right? Frame number and frame offset field. Frame number field and frame offset field. Now what else they have given? They have given the page size as 2 power 12 bytes. What does it mean? Frame size will also be equal to 2 power 12 bytes. If the frame size is equal to 2 power 12 bytes, then the number of bits in frame offset field will be equal to 12, right? And so frame offset field will have 12 bits. Now if this is 28 bits and this is 12 bits, then this will be equal to 28 minus 12, right? 28 minus 12 is nothing but 16. So frame number field will have 16 bits. Fine. Now what else we can calculate? Now let's fill out, okay? Whatever is possible, let's fill out. What is the logical address space? We don't know, right? We have not calculated the large. I think we can calculate from this, right? See, they have given that number of pages equal to 2 power 8. What does it mean? Now I am considering the logical address. They have given that number of pages equal to 2 power 8, which means page number field will have 8 bits. Also they have given that page size equal to 2 power 12 bytes. Then what does it mean? Page offset field will have 12 bits. So 12 plus 8 is nothing but, this is page offset. 8 plus 12 is nothing but 20, and so logical address is nothing but 20 bits. If logical address equal to 20 bits and if it is a byte addressable system, then the logical address space is nothing but 2 power 20 bytes. Or I can also say that as 1 MB process. Fine. What is the number of bits in logical address? Number of bits in logical address is nothing but 20 bits, right? You have calculated it. What is the number of bits in physical address? It is nothing but 28 bits. What is the number of bits in page offset field? Number of bits in page offset field is nothing but 12 bits, right? So it is 12 bits. Now what is the number of frames? Number of frames really depends on frame number field, right? Here frame number field has 16 bits, and so the number of frames is nothing but 2 power 16 frames. Now what is the page table entry size? That really depends on frame number field. Frame number field has 16 bits, and so page table entry size is nothing but 16 bits. Now what is the page table size? That depends on number of page table entries into size of a single entry, right? Now number of page table entries is nothing but number of pages, and we know that number of pages is nothing but 2 power 8. So there are 2 power 8 entries, and size of single entry depends on frame number, and frame number field has 16 bits, and so it is 16 bits per entry. Again entry and entry will get cancelled. So 2 power 8 into 2 power 4 is nothing but 2 power 12 bits. If I want, I can divide it by 8 in order to get the answer in bytes. And so 2 power 12 divided by 2 power 3 is 2 power 9. So 2 power 9 bytes is the total size of the page table in bytes. Okay.